All right, we're going to review similar figures. In similar figures, the corresponding sides are proportional and the corresponding angles are congruent. You need to memorize this sentence. Because the sides are proportional, that is why we are able to set up a proportion to solve for a missing side length. Okay, the angles are congruent. That means they have the same measure, the corresponding angle. So if this is 60, this is 60 because they correspond. They're in the same spot on the similar figure. The sides are proportional, so the corresponding sides share that proportional relationship. So if we look at triangle ABC, it is similar to triangle DEF. And we want to know, what is the perimeter of triangle DEF? Well, we know this side is 15, and it matches up with this side over here that we don't know. This is 40, and it corresponds to this side here that's 60. And then this is 30, and it will correspond to this side here. So we have to find these two missing sides to be able to find the perimeter. So I went ahead and set up my proportion, and I just like to call it big to little. I just can memorize one thing that way, and it keeps everything simple. So on the big triangle, I have a side length of 60 that I know, and it corresponds on the little triangle to the side length of 40. And I set that equal to, on the big triangle, my unknown of x, and 15 on the little triangle. And you'll notice these triangles are turned, and you might want to redraw the triangle if you can't match up the sides. I always use the highlighters to help me match up the sides. So once we get our proportion set up, then we just cross multiply 40 times x and 60 times 15. And then we multiply that out, so we get 40x is equal to 900. To get rid of the 40, we're going to do the opposite of multiply by 40, so we divide by 40. What we do to one side, we do to the other side, and then 90 divided by 40 gives me 22.5, or 22 and 5/10. So this missing side length here is 22 and 5/10. Then I've set up another proportion to find this missing side length. Even though we now know what this side is, it's always best to use the information that the problem gave you. So I'm going to set up the same ratio here, 60 to 40, because that was what was from the problem, instead of using my 15 and my 22.5. So on the big triangle, again, this unshaded side will be my unknown, and it matches up or corresponds to the 30. So here's my second proportion. Again, I use cross product, so 40 times x is equal to 60 times 30. I want to multiply the 60 times 30 to get the 1800. To get rid of multiply by 40, I divide by 40. What I do to one side, I do to the other side, and then 1800 divided by 40 gives me 45. So this side length over here would be 45. And I now know all of my side lengths to be able to find the perimeter of this triangle. So I'm just going to add the sides up. Lining up my decimals, 60 plus 22.5, or 22 and 5/10, and 45 gives me 127 and 5/10 as the perimeter of triangle DEF. Now, the way that I set up my proportion, okay, this is just one way. I could have labeled it with the side lengths. I could have done base and height. I could have done several different things. So this proportion right here is rewritten 4 different ways down here. It doesn't matter how you set your proportion up, as long as you label it and keep everything in the right location. Because all 4 of these proportions are set up differently, but they're the same proportion. Because if you look at your cross products, you're going to wind up multiplying 60 times 15, 15 times 60, 60 times 15, 15 times 60. So it's all going to give you the same second step here. So 4 different ways to write the same proportion.